Hello everybody, I've got an example here for chapter 2.7, 2.8. As you see, a person is pulling a cord, a rope, chain, whatever you want to call it, with a force of 70 pounds, and he's pulling at point B from point A. So he's pulling on that pole or whatever along the z-axis. Point A is from 0x, 0y, and 30 up in the z-axis, and point B, where he's standing at, is 12 feet. We'll call these feet. I know the point A has feet, but point B doesn't, but it's in feet. So it's going to be 12 feet in the x, and that's positive. And then if you notice, he's on the negative side of the y-axis of negative 8 feet. And then the point that he's pulling from is 6 feet, so he's kind of has that rope over his head, kind of pulling down. So I'm asking you to show the vector as a position vector or a Cartesian vector, whatever you want to call it, once you compute the direction. And then is there any way to solve your work or check your solution? So my approach on this problem, let's see, maybe you want to write down your approach and then come back to the video and compare to mine. Okay, so my approach would be to find the position vector r. And then secondly, I would solve for my magnitude. 3, I would solve for my unit vector. So really my approach here are my steps, right? And then point 4, or the fourth step I would do is I would multiply the force, so the 70 pounds, times my unit vector to show how much force is being pulled in each direction. So we're going to know that I have some force being pulled in the x, which is going to be something like this. Some force in the x. I'm going to have some force in the y being pulled here. And I'm going to have some force in the y being pulled down. So notice that this x is going to be positive. My y and my z are going to be negative. This is z. Okay, so let's get started. Maybe you want to pause the video and see if you can write out your position vector, maybe solve for your magnitude, and maybe even solve for your unit vector, and then come back. Alright, so my unit vector, position r, or my vector r, remember this is just in relation to distance, So this is going to be 12 minus 0, I, plus a negative 8 minus 0, that's j, and then I've got plus 6 minus 30 in the z direction, and that's all in feet. So if you notice, I'm going from here along the x-axis to 12. That's how I got 12 minus 0. So rewriting this, you get 12i minus 8j minus 24k. Remember, I told you we're going to be positive in the x, negative in the y, and negative in the z, and you can see that that's starting to happen. And in the future, you're going to start getting really good at this. You're going to be able to look at the figure and be able to compute or to write out your position vector pretty quickly. My magnitude is I'm squaring each of these. And take the square root. When I do this, the magnitude came out to be 28 feet. And so my position, or my unit vector, is just my position vector divided by its magnitude. So you get 12 over 28i plus, or we'll say minus 8 over 28j and minus 24 over 28k. So then I'm just going to write out the answer up here. So when I compute that in my calculator, I got good. So now I have my steps. Let's see what I've accomplished so far. I've done 1, I've done 2, I've done 3. Now the last thing I'm going to do is I'm going to show the magnitude force in each direction. So I'm going to multiply the force of 70 pounds times my unit vector. So it's 70 pounds times the same number up here. I wish this had a copy and paste thing. I'm sorry about my voice. It's starting to allergies or something getting to me. Okay. So if I multiply 70 throughout this, distribute the 70 throughout the unit vector, I get a nice number of 30i minus 20j minus 60k. That's all in pounds. That's my force. So coming back up here, I could write my answers. My force in the x is 30 pounds. My force in the y would be 20 pounds. And my force in the z would be 60 pounds. Now, why don't I write the negative? Well, because I'm showing it in the negative. Now, if you did this, if you said 30 squared plus a negative 20 squared plus a negative 60 squared, what do you think you're going to get? Well, let's just try it. Maybe I can do it on my calculator here. So I got 30 squared plus 20 squared plus 60 squared all equals 4,900. So if I divide that, or square root of that, 4,900, where is the square root on this thing? You get 70. Which should be 70. So that was kind of one way you could kind of quickly check to see if you had your position vectors in place correctly. One thing on those problems that a lot of students get wrong is the position vector. And if you get your position vector wrong, you can see that everything else following that is going to have an incorrect answer. So make sure that you double check your position vectors in order to double check them just to make sure that you're on the right track. Thank you for listening.